Okay, you guys there?
Doctor?
Yes, yes, doctor.
I can't seem to chat because it says that I'm not a team member.
Same with me. I can't type in chat.
Okay, let me open up the setting first. Meeting option. Okay. Okay, can you try now, everyone? Can you try to chat in the chat box?
I still can't, Doctor. Or should I reconnect?
Okay. All right, it's okay. I will try to fix this up. Okay. I would like to hear from your opinion. What do you know about stability? What's the stability can relate in your daily life?
When we walk,
Okay, when you walk, what happened? Do you stable walking?
yes.
Okay, why make you stable?
Symmetry object.
Symmetry of that. So your body symmetry. Who said that? Symmetry. Shofi?
Could it be something like when we accidentally trip and get back up to our original state?
Okay. That is like an engineering answer. Okay.
If the GM is positive, then the body is stable.
Which one? DM?
Yeah, GM.
Okay, that means you have read through the lecture not before the class, right?
Yes.
Okay, so I can see because the reason I asked you the question because I want to look at whether you have read through the lecture not before the class. Okay.
So I approve.
Huh?
I approved your point that I've read.
Okay. So basically, if you want to understand clearly what is the stability, okay, I think I cannot hear your voice. All right, I believe you have this lecture note. All right, you can look at here. Okay, what it means by a stable. So can you see here? We have the curve downward, and then we have the ball. So the stable means it is not moving. All right. I mean, it is not fall, it is not having a difficulty. For example, you try to put the force, external force. Do you think what happened to the ball? Is it going to the original state or going to somewhere else? Definitely, the ball going to be in the original state, right? All right, for example, you put the force here. Okay, we have the external force. You try to push, having the force. And then this ball will move and finally will go to the original position. So that means it is called a stable for this case. What happened for this one? You try to push with certain amount of force, and what happened to the ball? It's going to be in the original position?
No. No.
Okay, maybe somewhere else here.
Yes.
Okay, so it is not at the reference line, reference point. Okay, you look at here, it is a reference. So what happened to this case? Okay. What happened to this case? When you try to to make one little touch.
Falling down.
Okay, will fall down. Definitely will fall down. So even no external forces, any external forces, so the ball still will fall down because it is unstable. Okay, so maybe it will fall down this way or this way. So this is very unstable. Okay, for this case, this is neutrally stable because without touching, it is still in the original position. When you touch, it will move to other position. So that is what we call the stability for this case. Okay, so far you guys understand what's the meanings of the stability for this case?
Yes, doctor.
Okay, so for the let's take a look of the stability in detail. All right, this is the case of unstable. All right, you can see here why this is unstable. Okay, because the center of gravity of the body is above the centroid C, which is center of buoyancy. So a small angular rotation lead to a moment that increase the rotation unstable. Okay, in your own word, what do you understand of this case? I would like your opinion.
Doctor, is it like when you try to stand on one leg, then you will be unstable?
Okay, all right. That is the previous case. Okay, for this case, we have the arbitrary shape. Okay.
Okay.
Okay, for example, this is the arbitrary shape. Any kind of shape. Okay, all right. So, what do you think of the center of gravity?
Doctor,
Yes.
so rotation, when rotation occurs in a body, it occurs, the pivot point tends to be at the centroid of the body. So when the center of mass is above the centroid, so what happens is that the body will try to the center of mass will try to come below the centroid as the most force is over there, and because of the gravity acting down, it will move within a faster angular and will come down to below the center of below the centroid.
Okay, that's correct. You can see we have the rotation because of the two forces. Okay, all right. Let's take a look of this case. We have the arbitrary shape, whatever shape. Okay, definitely we have the center of gravity. Do you know what is the center of gravity? The center of gravity is the center of the weight. All right. So for example, we have the center of gravity, which is the gravity acting on the weight. Okay, for example, in this case, this is G. All right, G directly depends on the weight of the object. All right. So what is the C? The centroid, center of buoyancy. Do you think the center of buoyancy the same with G or different? And why different? Please help me to answer that. The centroid or the center of buoyancy. Do you think the center of buoyancy same with G? Obviously, you can see it is different for this case. Why it is different? Anyone? Why the C different with G? This is based on the previous lecture. about the buoyancy. Can you try to relate with the buoyancy that we have learned before?
Doctor.
Okay.
Center of buoyancy means when you submerge the body where means the place where the buoyancy force will act. That's the center of buoyancy. And
Okay, that's correct. For example, for this part, okay, floating into the water. We have the water. Okay, we have the water here. Okay, what do you think of the center of buoyancy? The center of buoyancy will act of the displacement, what we call the displace. The buoyancy force will act on the displaced liquid or displaced water. Okay, for this one, what is the displaced one? Okay, I try to draw the displaced. This is what we call a displaced. Can you see here? Okay, can you see this is a displaced liquid based on this one, right? Okay, what do you think? Okay, when we consider the buoyancy force, we must consider the displaced liquid. This is a displaced liquid or fluid. Okay, what do you think of the buoyancy force act? At the center of displaced liquid, right? Everyone, are you agree? At the center of...
Yes, sir.
Okay, maybe the center is here.
Yes, doctor.
This is C. Alright, for this case, C is where the buoyancy force acting. So when we try to draw here, maybe in this case. Do you guys understand how to differentiate?
Okay.
The
How to-
upper submerged part makes the center of gravity move a bit out to the other side.
Okay, clear about this. How to locate the C? The C depends on the displaced fluid. Okay. The gravity depends on the total weight, the total of this object. So the total include the top surface. For the centroid, it depends on the displaced fluid. For this case only. Okay, you guys understand?
Yes, doctor.
Yes,
So, okay. So, however, this will not be stable if you can see, all right, the gravity, okay, the center of gravity of the body is above the centroid. All right, so the small angular rotation leads to a moment that increase rotation. Okay, can you see? For example, okay, I try to use this new one. Okay. Okay, can you see this is a calculator? Everyone can see? I try to...
Yes.
Okay, everyone. Can you
Yes.
see now my full screen?
Yes, doctor.
Okay.
Yes, doctor.
I try to push this one and push this one. I try to push. What do you think? I try to push.
Broke.
Not will break. What do you think? I try to push on the left and on the right side. I try to push. Maybe I will have the rotation, right? Like this.
Yes.
Do you think that is the case? I try to push, it will have the rotation. Okay, do you now you understand?
Yes.
So now for this case, I try to push, I might have the rotation. So for this case, this is unstable. Okay, maybe like this, I try to push. Okay, so this is what it means. When the gravity on top of center of buoyancy, okay, the G is more than C. So this is unstable. Can you see? Because of this, they try to push to each other and will cause the rotation. So this case is not stable. It will move. All right. For this case, the neutral, what do you think of this? The center of buoyancy is at the same point to the center of gravity. Okay. For example, this is the arbitrary shape, and then fully submerged into the water. So what do you think of the displaced liquid? Is it the same of here?
Doctor, I cannot see
We
the screen.
cannot see the
Okay,
screen.
sorry. Okay. Okay. Okay, can you see this is the neutral? Everyone, can you see for this case?
Yes.
Okay, for this case, this is neutral stability because the center of gravity and the centroid coincide at the same point here. Okay, this is the reason because, for example, you have the arbitrary shape fully submerged into the water. What do you think of the displaced liquid? Is it the same here?
No, it will be more. It will have vertical displacement, the shape.
Okay, I mean the displaced fluid when this object fully submerged. What do you think of the displaced fluid?
Will be more.
Is it the same? Is it like this? Or fully?
Fully.
Okay, so can you see when this is object fully submerged into the water, and then the displaced fluid will have the same shape. So that is why the center of buoyancy will have the same location at the center of gravity. This is G. This is C. Okay, when we try to relate this one, it is coincide with C and G. When one point coincide to each other, we can call as a neutral. Okay, everyone. Do you get it?
Yes, doctor.
All right. Okay. So for this case, the next is the stable. Okay, why do you think of a stable? Because as the centers of gravity is below the centroid, right? This is case as the center of gravity below the centroid, a small angular rotation provides a restoring moment, and the body is stable. All right. For example, okay, I try to. Okay, for example, can you see my calculator? Everyone?
Yes. Yes.
Okay,
Yes.
I try to pull. Do you think it will have the rotation?
Yes.
No.
I try to pull. Do you think it will be like this? Like this?
No.
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 I try to pull.
No.
Definitely, it will not have the rotation.
Rotation.
Compare, you try to push. Okay, so definitely you will have the rotation, slightly rotation. All right. This is because when you try to pull these two end point, you will have the restoring moment. Okay, it will restore the moment. So it try to prevent this object from rotation.
Yes.
Okay, so that is what it means. Okay, so far you guys understand, yeah? Okay, so this is the basics of stability. how to know the object is stable. Okay, for this case, can you see this is a ship? All right.
Yes.
Okay, this is the real case that we're going to apply the concept of stability in your fluid mechanics. Okay, how do we determine whether the object is stable or not? All right, it is based on metacentric height. We call as a GM. GM is the distance from the G to the points of intersections of the buoyant force before rotation, which is A, with the buoyancy force after the rotation. Okay, let me draw to you what it means by before and after. Okay, this is before and this is before and this is after. Okay, where is your buoyancy force? The buoyancy force will act in this way, right? Can you see? This is buoyancy force. So try to draw the line from the buoyancy force to the top. Okay, everyone, do you get it now? This is the line of buoyancy force before the rotation. Can you see here? Do you guys understand so far?
Yes.
Yes, doctor. Yes.
Okay. All right. After, where is the, okay. After the rotation, you can see this ship try to have the rotation. Okay. And then, do you think the displaced liquid the same before here? Do you think the displaced liquid is the same as A?
No, doctor.
Okay, where is the displaced liquid? This is the, can you see here? This is?
Yes.
This is a displaced
Liquid.
liquid. What do you think of this? Where is the displaced liquid? Definitely from here.
In the center.
Okay, can you see? This is the displaced fluid or liquid. Okay, this is displaced fluid. Do you think the displaced fluid is the same as before?
No.
It is. It is totally different, right? It is totally different. The displaced fluid before is totally different with displaced fluid of after. Okay, so when the displaced fluid is different, what do you think of the buoyancy force? The buoyancy force is different or the same?
Different.
Definitely different. Okay, everyone, do you get it? Now you understand? So now, okay, why do you request for week?
Yes, why different?
Why different? What? Okay, what do you mean different? Which part?
The last part.
The last part. This one, buoyancy force.
Yes.
Okay, the buoyancy force directly relate to equal to gamma multiply with
Volume of the displaced fluid.
yes, displaced fluid. Okay, can you see the FB is directly proportional to V displaced fluid. Can you see now? The displaced fluid before is not same with the after. So what do you think of the buoyancy force? Is it the same or different?
Different.
Different. Okay. Okay, for this case, I try to draw like this. This is better. This is volume. This is volume of displaced before. It's not equal to the volume of displaced after. Okay, that is why the buoyancy before is not also equal to the buoyancy after. Can you see this relationship? Okay. So, for this part, this is the volume displaced before. So this is the line of action. Okay, I draw here the line of action, the purple color. Okay, for this case, what do you think of the buoyancy force? Definitely different from the before. So the line of action may be here. Okay, this is the line of action, buoyancy force. Remember that the buoyancy force always act upward, vertically upward. So this is the new line. Okay, everyone. Do you clear about this? The buoyancy force now change. This is after. Do you guys please respond? I want to see your feedback.
Clear, Doctor.
Yes.
Okay. So this is all right. Let me use a different color. Okay, this is after the new buoyancy force. This is the line of action. All right, and then the before is this line, which is refer to this line, right? Okay, where is the line of intersection? Before and after. At point M or at point
M.
point M. All right. So the distance from point M, yeah, okay, to the point of G, okay. Okay, can you see here? The metacentric height, GM, is the distance from G to the point of intersection. Now you know where is the how to get the intersection, everyone?
Understand, Doctor.
Okay, intersection before rotation, which is this one. This is the line of action. And after the rotation, which is the orange, which is the orange color. So this is the intersection. Thus, the distance from G, which is the center of gravity, to this point M, when it is positive, it is stable. Okay. When the GM, the metacentric height is negative, it is unstable. Okay, for example, this is object. Okay, and this is the, okay, I try to use the color. Okay, this is G. Okay, what it means a positive when it is above the G. This is M. This height is positive or negative?
Positive.
Positive. Why positive?
Above G.
Okay, above G. Can you see this one? This is what we call. What we call this one, the triangle one.
Our reference.
As a reference, all right? When it is above the G, it is positive displacement, all right? For example, when you have this M, it is below the G. Do you think the GM is positive or negative?
Negative.
Negative. Why negative?
Below
Below the gravity, center of gravity. When the GM is above the G, that means it is positive. Okay. Do you know why? Okay, let me show you the case here. Okay. This is G and this is M. Okay. Where do you think of the wake will act? Where is the location of wake? The wake of the object, W-E-I-G-H-T. At the G, right? So the wake will point downward. Where do you think of the buoyancy act? The buoyancy force will act. Which location?
At G.
The buoyancy force.
At the center.
Okay, actually, the buoyancy force will act at the point of intersection. Can you see this is before and after? Can you see here, M? Alright. So the buoyancy force will act at the point M. Do you think the buoyancy force will act upward or downward? Upward. Okay, can you see? Do you think this is stable? Stable or not stable? Stable. Why stable? Because it try to pull one another. Okay, everyone. Okay, for this case, this is versus this one. Okay, this is center of gravity. This is G, and this is M. Okay, where is the location of gravity?
G.
The center.
At the G, downward, right?
Yes.
Okay, where's the location of buoyancy force?
At M, down also.
At the buoyancy force.
At M, down.
Upward.
I think at the M, is it upward or downward, the buoyancy force?
Downward.
Downward.
Like this, right?
Up. Yes. Up. Up.
Up or down, the buoyancy force?
Up.
Up.
Because center of gravity up.
Okay, so this is FB, and this is the weight. So do you think this is stable? When you try to push one another?
No, I think that's stable.
It will cause the slightly rotation. So this is not stable. This is stable. Okay, everyone, do you get it so far? Do you clear about this?
Yes.
Okay, so how to calculate the GM? Alright, this is the equation. Okay, please use this.
Excuse me, doctor.
Yes?
I have question for case 2, which when it is not stable.
Okay.
It's not stable because if we have slightly different, like they are not aligned, they have some sort of angle, so we have rotation. But what if we don't have any angle, they are aligned?
Okay. For example, this force is a little bit more than this weight. What do you think?
Yeah, we will have rotation. But what
Yes.
if they are aligned in the same line?
Even though it is aligned, but still it is unstable because, as I mentioned previously, if we have external force, do you think this is gonna have this will rotate at the original position? When we have some disturbance, do you think it's going to have at the original position? No, right? For the stable one, for the not stable one. For the stable one, all right, if you try to cause the disturbance, you try to rotate, you try to push in this direction.
Yes.
Do you think it will go to the original state, original position?
Yes.
Yes. So that one is a stable or not stable?
Yeah, stable, doctor.
Okay, for this case, even it is aligned, okay, it is fixed, and then you cause a small disturbance. Do you think it will go to the original position?
No, not.
No. So that means this is not stable. Okay, clear.
Yes, clear, doctor.
Okay, so how to calculate the GM? Okay, this is the formula. Please write it down. Okay, GM. Okay, this is the symbol equal to I naught. Okay, this is the inertia. Okay, I think try to use this one. It's harder to. Okay, the GM. Okay, is equal to I naught over, this is a moment, over the displaced volume minus CG. Okay, so CG is actually the centroid to the gravity. Okay, please write it down, everyone. Okay. You guys okay so far? Okay. I think we go to this one and then we end our session. All right. Okay. So now we have this shape. All right. A 0.25 meter diameter cylinder is 0.25 meter long and composed of material with specific weight of 8,000 Newton per meter cubic. Will it float in the water with the horizontal end? Okay. Everyone, can you see my question here?
Yes, doctor, we can.
Yes, doctor.
Okay. So what it means here, the horizontal end is where you look at from the top. So this is your eye. Okay. What do you see of this? What do you see of this from the top view? What's the shape? Is it rectangular or circle?
Rectangular.
Rectangle.
Okay, can you read first? Can you please understand first the question?
It
We
will be a
will
bit
see
circular
circle, doctor.
on the top.
Okay, on the top, it is a 0.25 meter diameter cylinder. This is cylinder. Alright. 0.25 meter long and composed of material with the specific weight of 8,000. This is gamma lah. Will it float in the water with the horizontal end? Okay. For this case, okay, I try to explain to you step by step what it means by horizontal end. Okay, first you need to look at from the top view. What happens when you look at from the top view? What can you see from the top view? Is it a cylinder? Is it the circle or rectangular?
Circle.
Circle.
Circle. Okay. It is from the top view. Okay, everyone. Now you can use. Now you need to understand from the top view. So what the question asks here: Will it float? Will it float in the water with the horizontal end? That means will it float? Okay. Will it float or will it stable? This is the question asked. Is it stable? Okay, what it means here is actually, will it stable in the water with the horizontal end? That means when we place this object, do you think this is stable or it will topple down? It will topple like this or topple like this? Okay, so this is actually the question asked. Okay, will it floats in water with the horizontal end? That means once you try to put the object into the water, will it float stably, nicely, or it will topple down? Okay, so we need to analyze whether this object will topple or not. Okay, it depends on the stability of the object. Okay, so far you guys understand the question?
Understand, Doctor.
Okay, so when you see this keyword, will it float in the water? That means it is want to ask your understanding on the stability. Okay, so when this considered as a stability, you need to calculate the metacentric height, which is what's the formula of GM? The formula for GM is, as I mentioned before, it is GM equal to, okay, I naught, there's a moment, over displaced volume, okay, minus with CG. This is distance, okay. So for this case, we need to know whether this is stable or not, depend on the value of GM. If the GM is positive, that means it. Guys, are you there?
Yes,
Yes,
Doctor.
Doctor.
Yes, Doctor.
Okay.
Yes, Doctor.
When the GM is positive, that means it is stable. When it is negative, it is unstable. Simple. Okay. So the first step, we need to find the I naught, which is the second moments, all right, of the object. Okay. For this case, for the I naught, this is reflect. Okay. The I naught directly reflect to the our viewpoint from the top. So what do you think of the I naught shape? Is it the rectangular or the circular shape?
Circular.
Circular shape.
Okay, so the I naught will directly refer to the circular shape. So you need to refer to the this we call the geometric property. Okay, where is the circular shape? Okay, can you see this one? This
Yes,
one, right?
Yes.
Okay. So what's the formula for I naught? 1 over 4 pi r, the power of 4. It doesn't matter whether it is x or it is y, it is the same thing. Okay, everyone. So you need to calculate, this is step number 1. Step number 2, you need to calculate the I naught, which is 1 over 4 pi r, the power of 4. Okay, this one. So, what do you think of the radius? Is it given?
No, Doctor.
Okay, so what's the radius? Radius is equal to diameter divided with 2. So, diameter is 0.25 divided with 2. What's the value?
0.125.
0.125 meter. Okay, so let's substitute into the second moment of area, which is 1 over 4 pi r, which is 0.125, the power of 4. Please help me. Everyone?
1.92 times 10 to the power of negative 4.
Okay, correct. 0.000192, right?
Yes.
Okay, m the power of 4. Remember, this is, okay, second moment of area having the power of 4. So this is should be the power of 4. Okay, now we get the I naught, all right, the second moment of area. So next we need to find the, can you see the displaced volume? Okay, what do you think of the displaced volume? How to get the displaced volume?
From the buoyancy equation.
Yes, perfect. Okay, now I try to draw again. This is cylinder, and then this is water. Okay, what do you think of the displaced? This is the displaced liquid, right? Okay. And then, what do you think of the forces involved? Do we have any other forces? What do you think of the force?
The weight
Okay, the weight. Where's the location of weight?
at the center.
The center of displaced liquid or the total object?
Total object at
The
E.
total object.
Total. So supposedly here, right? This is the gravity. So we'll act in this direction. Okay, do you have any other forces other than weight of the object?
The buoyancy.
The buoyancy force, right? At the object or at the displaced liquid?
At the displaced
liquid.
Yes, remember that the buoyancy force will act on the displaced liquid. So where's the center of displaced liquid? Is it on top of G or below G?
Below G at buoyancy.
Yes, this is C, right? So for example, this is the same. Should be the same from here. Okay, everyone. So this is the F B. Okay, let's try to do the equation. Summation of force in the y direction equal to 0. So FB minus W equal to 0. Do you get it, everyone? Are you clear so far?
Yes,
Yes,
doctor.
So FB equal to weight. Okay. Alright. So what's the formula of FB? Gamma multiply with
change in volume. And
what's
volume.
the formula of B? Buoyancy force is equal to gamma of the displaced liquid multiplied with the volume of displaced liquid. Okay. So, can I try to substitute here? Okay. So, FB here is a gamma. Gamma of what? Gamma of water. Okay, H2O. Okay, gamma of water. Alright, multiply with the displaced volume. So this is the displaced volume. Can you see here?
Yes.
Okay. So equal to the weight. Weight of what? This is weight of object.
Object.
Alright. So can we try to get the displaced volume here? If we try to move the other side. So the displaced fluid, okay, dF is equal to the weight of the object over gamma of water. Everyone, do you understand so far? Okay. Please respond. I want to look at your feedback. Okay, how to get the weight? The weight of the object is equal to mass multiplied with gravity, right? Are you agree? Okay.
Yes.
So the density equal to mass over volume. Can I try to replace this mass with rho V? Rho V G. And then rho G is equal to gamma. Okay, everyone.
Yes, doctor.
Okay.
Yes, doctor.
So rho G is a gamma multiplied with V. Okay, this is V of total object. So this is gamma of liquid or gamma of object? This one, everyone.
Gamma of the object.
Gamma of object, this is volume of object. Okay, how to get the gamma of object? Can you see here? The material composed of specific weight, which is gamma, 8,000. Now we already have the 8,000. Okay, so 8,000. Okay, this is gamma. The 8,000 here is a gamma of object. Multiply with the volume. What do you think of this volume? How to get the volume of total cylinder? What's the cross-sectional area of the circle? Pi
R square into height.
pi r squared, which is 0.125 squared, multiply with, this is cross-sectional area. To get the volume, multiply with
Height.
the height. The total height
0.25.
of 0.25. Okay, this is the weight. Divide with the specific weight of the water. What's the specific weight of water? 9,810. For those don't know how to get, specific weight of water is equal to rho multiplied with gravity, which is rho of water is 1,000 multiplied with gravity. Then you will get 9,810 Newton per meter cubic. Okay, everyone. So once you try to calculate this one, you will get the volume of displaced fluid will be 0.010, okay, 0 meter cubic. Okay, this is the volume of displaced liquid. So how to get this one, CG? Everyone, CG. Is CG given or not? CG. C to G. What's the value of CG? CG is equal to, can you see here? How to get the CG?
I think 0.125 minus 0.102.
Okay. Okay, remember that. What is CG? Previously, I told you. Sorry, what is a centroid? What is C? How to get the C?
Centroid
See here?
is the center of the displaced liquid.
Yes, center of displaced liquid. For example, from the center to the top is X. What do you think from here to here?
X over 2.
X over 2. This is X over 2. Alright. Let's take a look of this. What's the value of C? C. Okay, this is C. Okay. So, what's the value from here? Here to here?
1.02.
1 point?
Sorry,
Okay.
0.2.
Okay, everyone. How to get this value? Remember, the total displaced here, which is this value,
minus 1.
0.204. Sorry. It's not CG. C. Okay. C is equal to, from here, 0.204 divide with 2. So 0.102. Okay. So how to get this value CG?
0.125 minus 0.102.
So CG equal to 0.125.
125. Okay.
Okay. 0. This one, the total one, 0.204 minus 0.102. Okay, this one please don't look at here. This is given already. Okay, so what's the final answer of CG? 0.102. Okay, everyone. Okay, so try to substitute back into the equation. Okay, sorry. Okay, so the GM, so this is step number 4. GM equal to, okay, the formula is I naught, which is, what's the value? 0.000192 divide with the displaced volume, which is 0.0100 minus with CG, which is, okay, sorry. Okay, I think there is a mistake here. Okay. Okay. So, from here, okay.
CG is supposed to 0.023.
Okay, yes, 0.023. Okay, CG, yeah. Okay. So from the surface to the top is 0.204. And then this is the C. Okay, from here to here. Okay, so this one divide with 2, we will got the C, which is equal to 0.102 meter. Okay, 0.102 meter. So this is, okay, this is from top to here is not G. Okay, this one 0. Okay, from here to here, the CG is equal to 0.125 here minus here. Okay, 5 minus 0.102. Okay, so now you got the CG, which is 0.023. Okay, because previously I confused. Maybe this is not the G. Okay, the G is here. Alright. So from here to here is not from the bottom to the G. It is the surface only. So for the G case, it is half of the total length. Alright, 0.125. Okay, this one divide with 2. So you will get 0.023. Just substitute here 0.023. And finally, you will get the answer is negative 0.004 meter. Okay. So what do you think of this?
Unstable, Doctor.
Okay, so based on this answer, it is negative. That means it is unstable into the water. So it will not float stably with the end of horizontal. Okay. So I hope that after this you try to look at this recording video again for the revision and to improve your understanding of how to locate the I naught, which is the second moment of area, the V, which is the displaced volume, minus CG. Alright, the centroid to the center of gravity. Okay, the CG is
Hello,
quite
doctor.
tricky. Huh?
Hello, doctor.
Yes.
For the volume of displaced fluid, can I just use the pi r squared times the length of depth, the 0.204 meter?
You want to find the depth?
No, I mean the volume of displaced fluid. Can I just use pi r squared times 0.204 the volume of displaced?
Okay.
Yeah, instead of use the
entire cylinder
formula you given just now.
Yes. So for that case, delete this one. Okay. Basically, alright. Okay. Basically, this is not given, but I try to copy and paste from here. Can you see here? Basically, this height is not given. Okay. So you need to calculate on your own self. Okay. So your question might be correct if this is given. Okay.
Okay, thank you, doctor.
If this is not given, and then you need to find this one lah. Okay. Supposedly this is not given because this one I try to copy and paste directly from the internet lah. Okay. So supposedly it is not given. It is like this. So it is not given at all. Okay. So for that case, you need to find this H, and then you need to find the CG. Okay. Okay, I think that's all. It is already 2 o'clock. I have a meeting after this. Okay, I think that's all for today. Thank you for your time. Okay, please do scan your attendance before we end our session.
Excuse me, doctor.
Okay. Okay, what's your question?
Sorry. When is test one, please?
This one?
Test one.
Okay, might be in the week of 7.
So not stated yet.
Not stated yet.
Okay, thank you, doctor.
Okay.
Excuse me, sir.
Okay. Any other else?
Yeah, doctor, for the assignment, which is quiz, can you just extend it 1 day?
Okay. Why you need to extend?
Actually, I didn't do it.
Okay, I will extend. Okay. Regarding to the class, one of you said that we cannot have on Thursday, right? Thursday lunch. Anyone?
Yes, doctor, for me.
Okay, can we make it on Sunday, Monday, and Wednesday? Sunday, Monday, and Wednesday? Sorry, Sunday, Monday, and Tuesday, 1 to 2 o'clock. You guys okay with that?
Yes, doctor, for me, no problem.
Okay, Sunday, Monday, and Tuesday, yeah? 1 o'clock. 1 to 2 p.m.
But doctor, my Sunday is really packed. I start from 8 till 5 p.m. and the only gaps I left with lunch hour.
So, what day is that?
I mean like it's really bad. I don't know that whether it's already 4 subjects in a day.
Yes.
I'm not sure that I can
May
focus.
I know that subject?
Yeah,
May I
the
know that
subjects.
date? Is it on Monday?
It's
Tuesday or
on
Sunday?
Sunday.
Okay. Sunday. Okay. Monday, Tuesday. Okay, I think we fix on Monday, Monday, Tuesday, and Thursday. We fix for that schedule, 1 to 2. Later on, I will discuss for the new schedule. Yeah. Okay. For the tomorrow, I think tomorrow the first Ramadan. Okay. Okay. So for tomorrow, I think I have a meeting. Can we make it on Thursday? 1 to 2.
Yes, fine.
Yes, Doctor, no problem.
Okay. So I think that's all for today. I end my session with Assalamualaikum.
The assignment will be extended?
Yes, I will extend one day.
Doctor.
Waalaikumsalam.
Thank you, Doctor.
Okay, yes.
Thank you, Doctor.
Doctor?
Okay, any more? Any other question?
Yes, Doctor, I have one question.
Okay, what's your question?
Doctor, when I submitted did the quiz yesterday, after the deadline, can you give out all the answers? Because for some of the questions, we have 2 answers, like FB and FH. So my FH was matching, but my FB was not matching. So I did it with FH and I got the correct answer, but I want to know why.
Najmul.
Yeah.
After tomorrow, all the student has submit their assignment, then I will post the solution, okay?
All right. Thank you very much.
Okay.
Doctor, may I know what are the topics for the test 1?
Hydrostatic. Please take note, hydrostatic, buoyancy force. Sorry, not buoyancy force, buoyancy. Hydrostatic, buoyancy, and Bernoulli.
All right, thanks.
Okay, so tomorrow do not have any class. Will not have any class. We continue on Thursday. Yeah. Okay. I end my session with Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Doctor.
Waalaikumsalam.
Thank you, Doctor.